Hello everyone, in this video we will discuss the question number 54 of GATE 2019. An industrial fermenter containing 10,000 liter of medium needs to be sterilized. The initial spore concentration in the medium is 10 to the power 6 spores per ml. The desired probability of contamination after the sterilization is 10 to the power minus 3. The death rate of spores at 121 degrees Celsius is 4 minute inverse. Assume that there is no cell death during heating and cooling phases. Then the holding time of the sterilization process is how much in minute. So basically they have asked this question from the chapter of medium sterilization kinetics. So here the initial spore concentration it is given 10 to the power 6 spores per ml, and the desired probability of contamination after the sterilization is 10 to the power minus 3. So here it is given as the concentration spores per ml, but here after sterilization the or the spore concentration should be 10 to the power after the sterilization the spore amount should be, or spore count should be 10 to the power minus 3, but this is not the concentration, right? So unit of the initial cell is spores per ml, right? But here the unit is only spore. So now to convert it to spore per ml, we need to calculate in this way: 10 to the power minus 3 number of spore divided by volume of the fermenter, right? So that's how we will calculate the final spore concentration after the sterilization. The death rate of the spore at the 121 degrees Celsius is given at 4 minute inverse. So that shows that as the unit is time inverse, so the kinetics of the cell death in the sterilization is first order. So now they are asking that what is the holding time for the sterilization. So to solve this problem, first as we know that dn by dt equal to minus kn, right? So what is dn, what is n here? N is the number of viable cell. So dn by dt is equals to minus kn. That means the rate of death of the spores equals to minus k, which is the thermal death rate, into n. N is the viable cell number at any time t, right? And n naught is the initial viable cells, nt is the viable cells at time t, t is the sterilization time, and k equal to first order thermal death rate. So the rate equation of the spore death is dn by dt minus kn. So dn by n equals to minus k dt. So if we will integrate both the side from limit n naught to nt and t equal to 0 to t, because at the time t equal to 0 spore concentration was n or the spore number, viable spore number was n naught. At t equal to time t, suppose the viable cell number will be nt. So that's why we can put the limit from t equal to 0 to t and here n naught to nt. So we will get ln nt by n naught equals to minus kt, right? Which can also be rewritten as nt by n naught equal to exponential of minus kt. So according to the question, n naught is given initial viable cell concentration, which is 10 to the power 6 spore per ml, and nt is the viable cells at time t. So if our in this case, if t is the sterilization time which we are asked to find, so after that time t, and time t is the sterilization time, so after the time t the viable spore number will be 10 to the power minus 3, right? After the sterilization, 10 to the power minus 3. So nt will be number of spore divided by volume of the reactor. Volume of the reactor is 10,000 liter. So nt will be number of spores divided by volume of the reactor. Number of spores is 10 to the power minus 3, and the volume of the reactor is 10,000 liter. So if we will multiply with 1000, it will be ml. So so nt will be 10 to the power minus 10 if we will calculate it. So nt will be 10 to the power minus 10 ml inverse, right? Or 10 to the power minus 10 spores per ml, and k thermal death rate is 4 minute inverse, which is given. So now from this equation, ln nt by n naught equals to minus kt. So here as t equal to the time of sterilization, then nt will be the spore spore concentration after the sterilization process. So NT we know 10 to the power minus 10 we have calculated. So 10 to the power minus 10 divided by N naught is the initial viable cell. Initial viable cell is 10 to the power 6 equals to minus K equals to 4. So we will put 4 here into T. Right? T is the sterilization time. So ln 10 to the power minus 16 equals to minus 40, and we know that ln x equal to 2.303 log x base 10. So if we will convert it to log, then we will multiply it by 2.303. So 2.303 log 10 to the power minus 6 base 10 equal to minus 14. So and we know that 10 to the log of 10 to the power minus 16 base 10 will be minus 16. So 2.303 minus into minus 16 equals to minus 40. Minus minus cancelled out. So 2.303 into 16 equals to 40. So T equals to 2.303 into 16 by 4, which will come as 9.212 minute. Right? So our answer is T equals to 9.212 minute, which is the sterilization time. So here, according to this question, the holding time of the sterilization process should be 9.21 minute.